Good boy. Name Emerson Cora. While discussing the abstract model of embedded systems. This is a simplified way of understanding how embedded systems work. Instead of focusing on very technical details, the abstract model shows us the main parts and how they interact with each other. By the end of my report, you will see that this model is applied to almost every devices we use today. So, what is abstract model? So it's a level representation of an embedded system. That means we only focus on the important parts, not every small detail. For example, if you look at a map, you don't see every tree or every chair, just the main roads, landmarks, and the road. In the same way, the model gives us a big picture view of an embedded system, so it helps us understand how input becomes output inside the device. So main layers. The abstract model has three main layers: hardware, software, and application or user interface layer. First is hardware layer. This is the physical part of system. It includes the microcontroller or processor, memory, sensor, and actuator. Example, in a washing machine, the water level sensor and the spinning motor are part of the hardware layer. So that is a hardware layer. Second is software layer. This is the intelligence or brain of the system. It includes the firmware, driver, or sometimes a real-time operating system. Example, in the washing machine, the motion cycle should last and then the water. So that is the software layer. Third is application or user interface layer. This is where the user interacts with the system. It includes button, touchscreen, display, or even simple LED indicators. Example, the digital display and the start button of a microwave are part of the application layer. So that is the main layers of abstract model. Let's move to the low abstract model. This is one of the most important parts because it shows us how an embedded system actually works. Step. The can be summarized into three main stages: input, processing, and output. Break them down by one. First is input. This is where the system's information input can come into two forms. From the user, like when we press a button, touch a screen, or speak a voice command. And then from the environment, through sensors like temperature sensors, like light sensor, motion detectors, or pressure sensor. For example, in a smartphone, input can be your finger tapping on the screen. In a smart aircon, input can be the temperature sensor detect if the room is hot or cold. And the second is processing. This is the brainwork of the embedded system. It actually happens in the microcontroller or processor, but it is not just hardware, it also controlled by software or program. The processor takes the input data and interprets it. Then the software decides what action should be done. In some cases, the processor also stores the input in memory, compares it with previous data, or even runs calculations. For example, in a microwave, when you press 2 minutes, the processor doesn't just start the timer, it also controls the magnetron for heating, rotates the plate, and updates the display. In ABS car brake, the processor works extremely fast, calculating whenever the wheels are slipping, then adjusting the brake hundreds of times per second. Finally, we have output. This is the result or the action the system performs. It can be physical output like a motor turning, a door unlocking, or a heater turning on. Or it can be informal output like numbers on a display, an alarm sound, or a notification on a screen. To make it clear, let's walk through some example. So, microwave oven. Input. So input of microwave oven. Input. User presses a button. So the processor sets the timer and power. So the output, the food is heated, the plate spins, and the display shows the countdown. Now let's move on to the real life example of embedded system using abstract model. This will help us see how input, processing, and output are applied in different devices. So example number one is microwave oven. Input: the user presses the power button and sets the timer. So processing, the processor interprets the timer and power settings, then control the magnetron, which produce microwaves, and also controls the motor for the rotating plate. So the food is heated evenly. The display shows the countdown and it beeps when the cycle ends. So example number 2, pacemaker. So medical devices. Input, sensor detect the heartbeat rhythm. Processing, the software check if the heart rate is too slow or irregular. It compares the signal with the correct rhythm stored in memory. So the output, if you need the pacemaker, send the small electrical pulses to the heart to correct its beat. This is a life critical system, and unlike a microwave, the pacemaker cannot fail because it's directly keeping a person alive. So example number 3, smartphone. Input, you tap the touchscreen or use voice as command. Processing, the operating system interprets the input. For example, if you tap on Facebook, the OS processor you touch launches the app and manages background tasks. So the output is the screen changes to show the app. The speaker may produce sound and vibration motors may provide feedback. A smartphone is a very advanced embedded system because it combines many sensors and functions at once, like GPS, accelerometer, camera, and Wi-Fi. This example shows that embedded systems are not only in electronics like phones, but also in appliances, vehicles, hospitals, and even entire smart cities. They are everywhere, often invisible, but they make our life easier, safer, and more efficient.